Hi everyone. Today we are going to study a new topic. In yesterday's class we have discussed various identities in regular expressions. In that we have studied what you meant by Ardens Theorem. Ardens Theorem says that if R is the regular expression and we have a form R is equal to Q plus RP. That is, Q is a regular expression, P is a regular expression, here R is a regular expression, and R is redundant in both LHS and RHS. In that case, we can write it as R is equal to QP star. Okay, we have already discussed in earlier video. This is the procedure we are using here for a construction of a regular expression. If we have given a DFA or NFA, to convert into a regular expression, we use the famous identity, that is the Ardens Theorem, R is equal to QP star. So you must have in your mind R is equal to Q plus RP, R is equal to what? QP star. So I am leaving the identity here. So first of all, look at this DFA. So we have Q1, Q2 and Q3 as three states here. So first in constructing a regular expression from a DFA, first we write the equation for the Q1, Q2 and Q3. So I am writing the equation for Q1. Just listen it. First you when you listen the first one, writing the first state, you will get all the state by naturally. Okay, Q1 is equal to, look at this. This is the way state Q1. What all states or what all symbols is coming to Q1, that is Q1, from Q1 A is coming to Q1 itself, so we'll write Q1A. Okay, I am writing the equation for the state Q1. So for that I will write what all symbols coming to the state Q1. So in the state Q1, A is coming to the state Q1 itself, that is, it is self looping, so Q1A plus what you say, it's Q from Q2, B is coming to Q1, so Q2B. So from this, what you understand, the Q1 state's equation is equal to what alphabet it is coming to the state Q1 and from which state it is coming. It is self looping, so Q1A. Next one, from Q2 coming Q2 with B coming to A Q1, so Q2B. Plus this is the initial state plus epsilon. Okay, very simple. This is just, you understand the first one, you can by naturally you can write all the things. So you say Q2 is equal to, what do you mean by Q2? From Q2, Q3, from Q3 A is coming to, with A is coming to what? Q2, so Q3A. From Q3 with A coming to what? Q2, so Q3A. Next one, from Q1 with A coming to Q2, so plus Q1A. Okay, these are the two symbols or two alphabets or two strings coming to Q2. Next one you say for Q3. Q3, there is only one symbol or one input coming to Q3, that is Q2A. So this is equation number 1, this is equation number 2, this is equation number 3. Now to solve to get a regular expression using Ardens Theorem, you must look into the final state. So we want to build the regular expression corresponding to the final state. So which is the final state? Q3 is the final state, but to solve Q3 there is one variable here, isn't it? In a regular expression, as you know, there will be only terminal symbol, no non-terminal symbol will be there, but here there is a non-terminal symbol, so you must avoid this. Okay, so when you look into Q2, in Q2 there are two non-terminal symbols, Q3 and Q1, so you must avoid it because Q2 is substituted in what? Q3. Look at Q2, there is two non-terminal symbol, Q3 and Q1, and look at Q1, there is two non-terminal symbols Q1 and Q2. So how will you solve it? Very simple trick, but it will not work for all problems. So we will see 3 different problems in 3 different videos which I am giving you. This is the first video. First trick is look at the smallest expression. Okay, we want to, every time I will say, we want to build an expression with corresponding to the final state, and in your equations look at the smallest equation, that is Q3 is equal to Q2A. So substitute 3. So 3 is used in equation 2. So smallest expression is substituted in what? 2. So 3 into what will it become? 3 is substituted in 2. So Q2 is equal to Q2AA. That's very important. We are substituting here as what? Q3. So Q3 is equal to what? Q2A. So we are substituting here Q2A, but here already A is there. So don't forget to write that, otherwise your expression will be wrong. Plus what? Q1A. Okay. Look at this expression. Okay, this is equation number 4. Look at this expression. Is it in the form of Ardens theorem? Yes, because R is Q2. Here it's commutative because it can be write either like this. RP plus Q also can be written because this is commutative. So look at this. R is equal to, here R and P is what? This. Okay, P is this. What is Q? Q is this. Okay, this is Q, this is P, and this is what? R, and this is also what? R. Okay, so how will you write? R is equal to Q plus RP, then R is equal to what? QP star. So how will you can write? Q2 is equal to what? QP star. So Q1 A P star. P star means what? This is P A whole star. Okay, again I will say, when you look build an expression or an equation, look whether it can be simplified by using Ardens theorem. Here it can be simplified because in LHS and also in RHS an expression is being repeated. That is said by Ardens theorem. If an expression or a non-terminal is repeated in both LHS and RHS, it can be simplified by using what? Ardens theorem. So R is equal to what? R is equal to Q plus RP. Then R can be written as what? QP star. So Q is this and P star. Okay, this is equation number 5. So you can number it this as 4 also, but to understanding I made another number. This is what? Equation number 5. So look at equation number 5. Q2 is equal to, I will write it clearly, Q2 is equal to Q1AA the whole star. Okay, this is what? Q2. So look at here equation 1, it uses what? Q2. So I will substitute from here, I am writing to here. So this equation, that is equation number 5, I am substituting in equation number 1. 5 in 1. Okay, 5 in 1, what will become? Q1 is equal to Q1A plus Q1A whole star, then plus what? Epsilon. Look at here. Here Q1 and Q1 is same, so better bring out of the bracket, isn't it? So if for example, if 2 plus 6, what you will be do? 2 into 1 plus what? 3, isn't it? That's the same way. Q1 is same here, expression is same here, so you better take out. Common factors can be taken out of the bracket. So A plus what? A whole star plus what? Epsilon. Look at here. Look at here. This is again an Ardens theorem because LHS and RHS is containing what? The same expression or same non-terminals is repeated in both LHS and RHS. So what is R? R is Q1. Here R is Q1. P is what? This whole term is what? P. And what is Q? Q is epsilon. Epsilon can be Q. So what will it become? If this is, then R is equal to what? QP star. That is, if LHS and RHS contain same regular expression or regular variable or a non-terminal, this can be what? Avoided. Okay. So what will it become? A plus A into A star what? A plus A into A star whole star, because Q is what? Epsilon. In already we have studied in our regular expression, R dot epsilon is equal to epsilon dot R is equal to what? R. R means what? Regular expression. Regular expression dot concatenated with epsilon, and epsilon concatenated with regular expression gives what? R itself. So how it will become? Q is equal to A plus A into A star whole star. Okay, this is what? Q1. This is equation number 6. Okay, so we have solved an equation. This equation is solved without having what? Non-terminal. In every equation, when we said 3, 5, 4, all have what? Non-terminals in the what? RHS, but this has no non-terminal in the RHS. So look at here, non-terminal in the RHS. So this is the regular expression we wanted, but every time I say Q3 is the final state, so we must move to what? Q3. So Q3 we must move, but we have got only what? Q1. So substitute this equation again in what? 2. So what will become? 2 expression is what? Fifth equation, that is 2 is simplified as 5. So substitute 6 in 5. What will become? 6 in 5 when substituted, that is here Q1 is substituted by what? This. So A plus A into A star the whole star A into A star will it become, isn't it? This portion is substituted what? Here, and remaining portion I write as it, but this is the equation for what? Q2. We must get equation of Q3. So Q3 can be written as what? Q3. I am substituting this equation number 7. 7 is substituted in what? 3. So what will become? This equation, that is A plus A into A star the whole star A into A star into what? A. This A must be written. This is our what? Regular expression. Okay, once again I will say, when you get a deterministic automata or non-deterministic automata, first try the equations for the states and then see for the final state, that is Q3, whether it can be simplified as such. No, because it contains non-terminal. Again, when the non-terminal is looked for here, again it contains other non-terminal. So look it for the simple state and substitute in the other equation and solve it. Every time when you solve it, the last solving we get the last regular expression without non-terminals will be get from the state of which contains epsilon, and after solving this, again you do the reverse, substitute it, you will get what? Q3. This is a first example. Sometimes you may have some doubts. It will be cleared in our next lectures. Okay, thank you.